In this very video, we are going to be looking at how to transform homogeneous equation into an exact equation, to know the integrating factors responsible. Okay, so here we have if mxy plus nxy equal to 0 is homogeneous and mx plus ny is not equal to 0, then the integrating factor is 1 over mx plus ny. Okay, so we see an example here. We asked to solve this y squared dx plus x squared minus xy minus y squared dy equal to 0. Like we already see, the equation is a homogeneous equation. Now remember the condition for being homogeneous. We say that that f of lambda x lambda y must be equal to lambda raised to power n, then f of xy. Never forget that. Okay, what that means is if I substitute y and x for lambda x and lambda y, then if it is homogeneous, it must be f of xy times lambda raised to power any number. And we can try that quickly. Your y squared here can be lambda y all squared. Okay, then dx, then plus your x squared is lambda x all squared, or we can just say lambda squared x squared, minus xy means lambda x lambda y, replacing x with lambda x, y with lambda y, then minus y squared. Your y, that would be lambda squared y squared. Then you have your dy, okay, equal to 0. Now you can see that lambda squared is common. If I should open that, we will have lambda squared y squared dx plus lambda squared, okay, there's a bracket here, s squared minus this should be lambda squared xy, then minus lambda squared y squared dy, all equal to 0. So you can see that we can factorize lambda squared is common throughout, and if we do that, we have lambda squared into y squared dx plus open brackets x squared minus xy minus y squared dy, okay, which means lambda squared f of xy, because this is the whole of this now is a f of xy. So we are certain that this equation is a homogeneous equation. So we go ahead to find the integrating factor of the homogeneous equation that can help us convert to exact. Okay, so we say that the integrating factor for an homogeneous equation is 1 over mx plus ny. Okay, so you should know that your m, remember that this is your m and this is your n. So when we say mx, it means your m is y squared, so you have y squared then times x. That's the y squared x. That's exactly what we have here. Then your n, ny means multiply the whole of n with y. And so that's how we got x squared y minus xy squared minus y cubed. Okay, so you can see that this x squared y, sorry, that's a mistake. You can see that y squared x cancels x squared y. That's this, xy squared. Okay, so we are left with just x squared y minus y cubed, which is exactly what we have here, which if you like you can factorize, but we leave that. Okay, so this is our integrating factor. So this is our integrating factor. So what we do is we multiply the whole of this equation by the integrating factor. When you multiply this by the integrating factor, you get y squared over x squared y minus y cubed. And when you multiply this by the integrating factor, you get this, which is x squared minus xy minus y squared all over x squared y minus y cubed dy, okay, equal to 0. So at this point we can